In this video, we're going to talk about how to draw Lewis structures for polyatomic ions and understand how this then connects to forming our ionic compounds like we saw in chapter 4. So we've actually already drawn a Lewis structure for a polyatomic ion. Back in the previous video, we did NO2-. So that is a polyatomic ion. We've got multiple atoms with a charge. So the only difference here really is we're adding electrons if it's a negative charge, taking electrons away if it's a positive charge. The one other piece, and actually we didn't do it in the previous video, is when you have your Lewis structure, again, because it's an ion, the general practice is to put it in brackets with the charge on the outside. So let's see if we can do the same process here. So we're going to draw the Lewis structure for calcium carbonate. So notice we have calcium, which is a metal, which means overall this is an ionic compound. So the bond between calcium and carbonate is going to be ionic. However, carbonate is CO3, 2-, and within carbonate we have covalent bonds. So the carbon and oxygen are held together with covalent bonds. So let's focus on the Lewis structure for that first. So we have carbon that gives us 4 electrons, oxygen that gives us 6, and there's 3 of them. And then we have that -2 charge, which means I need to add 2 electrons to my total. So that is 24 electrons. So if we figure out what goes in the middle, it's going to be carbon, has the fewest electrons to start. We will then attach the 3 oxygens to it. Those 3 single bonds took 6 electrons, so we have 18 left. We'll put them as lone pairs on the outside. Each oxygen is going to need 6 more. So 6 times 3 was 18, which means I'm out of electrons. But if I look, carbon only has 6 electrons that it can count. So I'm going to take a double bond, it does not matter which one. Sorry, a lone pair, doesn't matter which one, and create a double bond. So I just moved those 2 electrons from the oxygen by itself down to share with carbon. So here's your carbonate. I'm going to redraw it over here so it's a little bit cleaner. And again, this has a -2 charge. So I'm going to put it in brackets and say that whole thing has a -2 charge. So that's the carbonate piece. Then we have calcium. So now we're thinking ionic. So calcium has a +2 charge. And if you remember back from chapter 4, the positive ions, we do not put any electrons around them because they've been removed. And then we put the charge outside brackets. So this whole piece here would be your Lewis structure for calcium carbonate. We have a combination of ionic between the calcium and the carbonate, and then covalent within the carbonate. Next example is sodium hydroxide. So sodium is your metal. Sodium is in group 1. It has a +1 charge. That is then going to be an ionic bond to the hydroxide. Hydroxide is OH with a -1 charge. So overall, I have to have a -1 charge here. Oxygen is going to give us 6 electrons. Hydrogen gives us 1. And then we have that -1 charge, so we'll add 1 more, which is a total of 8. Just 2 atoms, so we'll link them with a single bond. That took 2 electrons. So I have 6 left. Hydrogen already has a full octet with a single bond. So those 6 electrons are going to become lone pairs on the oxygen, and there's your hydroxide ion. So overall here we have the Lewis structure for sodium hydroxide. And again, ionic between the sodium and the hydroxide and covalent bonding within the hydroxide.